is shoot, don't shoot. Obviously, if the don't gets dropped off, you will have an entirely different outcome than if the don't arrives at the other end. So, you know, you have to watch out for that. And then in industrial applications, you'll see, mon back, stop. Boy, that stop had better get through there if you're talking to a guy who's operating a crane and he's, you know, moving an air conditioner onto the top of a building like this. So that really is a strong thing in terms of asterisk. I kind of, you know, make fun about the things that we occasionally see, but in general, the Linux operating system is extremely stable. It takes a licking, keeps on ticking. It's always there for you. Asterisk, you know, if you settle on a stable distro, more about the one we've settled on for this project, it just keeps working. You can take it for granted. It is always there for you. And then the other thing has to do with push-to-talk radio communications itself. The first go-to thing when you call on a customer who may have a telecommunications and IT department, and you talk to them about wireless communications, the first thing for them to fall back on is, well, yeah, we've got Wi-Fi. And so their mindset tends to say, let's squeeze all of our push-to-talk and our mobile person-to-person communications through Wi-Fi. And in some places, that may work through some miracle of physics or whatever the case may be. But in a lot of cases, you're trying to cover areas that it would cost you a fortune to try and get wall-to-wall, property line to property line Wi-Fi coverage. For example, to say in every room in the sub-basement we have an access point that covers every corner of the building up to the roof and out and including the people who have to roam the distant edges of the property line in their physical plant, that's not going to work. Whereas with push-to-talk radio, you can put up a master antenna on the center of a piece of property. All the radios can intercommunicate through that master antenna on a repeater, and you can cover it, whether it's a town, a city, a county, a college campus, a resort, a shopping center, or an industrial complex. And so that means instead of, you know, tons of access points, you've just got that one master site. And then again, a lot of places will have that in place. So when we talk about some of those commercial opportunities, a friend of mine said, you know, it all boils down to need, thing, time, price, and source. An asterisk can address each of those things. As we've talked, there's obviously a need for communications to increase people's productivity and improve safety and, you know, be a part of that whole 21st century communications revolution. The thing is there. It's asterisk. Asterisk has been out there for a long time. It's stable. These wireless slices and channel drivers and applications have been not only debugged by the amateur radio community, but there are lots of commercial applications out there. The time is now. It's ready. It's prime time. The world is calling, as Asterisk says. The price, well, that's part of the beauty of Asterisk, that the cost of getting into this can be fairly low. It can be scaled at an economical rate to suit the customer's need. And the source, well, of course, you're the source. That's an excellent source. There's an entire network of yourselves and your own communities and the worldwide community that make all this work. And communicate that to your customer, and that helps close that deal. Even though we're part of that community, there's a larger telecommunications community that, as you know, are your competition. For example, somebody may be trying to come into a resort or something like that. They're trying to sell a commodity, you know, telephone system. And because they don't have things like this and many of the features that Asterisk has, you can come in and say, yeah, they can do that, but look what we can do. And watch them sit there and struggle. You can hold the interest of your existing customers by going back to them and bringing them something new. I hope some of you have said, oh yeah, I've seen radios like this at one of my existing customers. Well, if you want to maintain and keep a customer, say, well, if you think that new phone system's great, wait till we move on to this. And prepare for that next step in unified communications. Some of the keynote issues that Kevin and the group brought up, Everything's coming together. Asterisk is going to have more and more channels, more and more ways of getting communications from point to point, and open new doors. So Asterisk, you know, I started the journey when I came in and didn't know Asterisk from anything, you know, from the well, anyway. I learned a lot about Asterisk, but it's great because it's a built-in, you know, it's born to bridge channels. It supports a wide variety of channels, and a lot of the wireless stuff, there was work already done on it in the project. You had the tremendous power of the dial plan logic for call processing and to automate repetitive things that happen in your customers and bring wireless into it. The worldwide developer network and a critical mass of active amateur radio contributors, testers, and users. There already was some work being done for push-to-talk radio for the amateur community. And let's talk a little bit about what it takes to put one of these systems together. Most push-to-talk radio networks have a physical layer. That's the point where you've got to connect from the push-to-talk radio environment to the Asterisk environment. And that's most typically on a radio, on a base station. There's an accessory connector on the back of the radio, their base station radio, and it's got receive audio that comes out from the mobile units. It's got transmit audio that can be sent back to the mobile units. It's got a push-to-talk switch, push-to-talk signal that's used to activate the local transmitter, and it's got a COR, or carrier-operated relay, because yes, in the old days it did go click every time a signal was received from the field. That's used for signaling back the other direction. And if you've got a long-time telco or telecom background, that sounds an awful lot like what was called a 4-wire E&M circuit, because that's pretty much what that interface is. It turned out that there was some work, as I'd mentioned, in Asterisk for PTT channel drivers. There was an existing product and a proprietary $500 card that would plug into a PC that used some routines or some capabilities of Zaptel, which became Dottie, and a thing called PCI radio that would let you interface radio communications devices. Myself and my customers are cheap, and so $500 to just play around with something was quite a barrier to entry, and it really even was in the amateur radio community. So I happen to know that the technology that was embodied in some of these simple, and I didn't bring one, I got a picture coming up, with the, you know, the USB audio devices that they use for headsets and things like that. Those actually have a great A to D converter and D to A converter in them, and they have a very important property in that they have a very wide frequency response. A lot of people say, why don't you just use the sound card for this? Well, the fact of the matter is, as we'll see coming up, we need to cover almost DC through the entire audio region, because in radio standards, there's signaling that occurs at very low frequencies. It's out-of-band signaling, quote unquote, only because it's in the region below 300 hertz. So I found this guy by the name of Jim Dixon, and he and I collaborated and created a channel driver called Chan USB Radio, and contributed that to the Asterisk project. I did some digital signal processing routines that are a part of that. A little more about that later. And you know, we got started with something that was truly could do the mission that commercial users required. And there's a variant of it called Chan Erd that's even further commercialized. So here's a picture of one of those typical sorts of little devices. In the corner, you'll see that's a basic USB audio device. It's been carefully hacked, and a cable that comes out that terminates at this end with, for those of you with a land mobile push-to-talk radio background, that plugs into the back of a Motorola 16-pin connector on the back of Motorola base stations. And plug that into both ends and load the channel drivers and have a nice day. And we talked about why that particular piece of hardware, why not sound cards, why those cables, why those connections. And that's because in these radios there is selective signaling. Remember the old garage door effect, where you and your neighbors and everybody, when you push the button on your garage door opener, are really transmitting on the same frequency, but you've all got a different coded message that's being sent to identify yourselves. Well, formats like that are used in land mobile radio. And one of my contributions to the project was the digital signal processing routines to be able to encode and decode those signals for selective signaling. And if you'll excuse me, I'm going to do something here. That's Jim Dixon as we speak, playing with something on his system in Coarse Gold, California. And I was going to try and see if I could catch him and say, hey, Jim, want to be part of a demo? Let's try this real quick. Yeah, I know. Hey, WB6NIL, W9SH here. All right, well, you couldn't make it to Astrocon this year, but you are now part of a Astrocon PTT radio demonstration. Say hi to a group of guys sitting in a conference room in Washington, D.C. All right, fine business. I will tell everybody what they just heard. But thank you for coming back to me. WB6NIL, W9SH. We may get back to you later. W9SH. So there you go. He's in the back of his van coming down the mountain. So we'll tell you how that worked here in a little second. He's, like I said, he's out in Coarse Gold, California. Outside of Yosemite Park in California. And now back to our regularly scheduled program, which we had gone through that. Oop, let me get back there. Don't jump through it. Okay, applications and features. You know, those are the things you bring to your customers that they like, that keeps them coming. The buzzwords are interoperable, unified communications. What they can do is they can eliminate or combine dispatcher and operator functions. You can use the dial plan to bring them advanced features and control of their processes. We even do things like contact closure inputs and outputs. So somebody at the back door can push a button and the night watchman can be walking around and get a message that says that there's somebody with a delivery at the back door. He can push the buttons on his wireless device and unlock a gate. Those sorts of things, calling trees, text-to-speech. It's asterisk, you know, the sky's the limit. But one of the things that's kind of the killer app, and you just saw a demonstration of it, is that it used to be the exclusive domain of high-budget public safety dispatch centers to have a computer-aided dispatch system. Well, you know, not anymore. There is a free client that's a part of this project called EAX RPT. It speaks EAX, IAX2 protocol,